Hello and welcome to Maths with Hudon. To all my students all over the world, I say you are welcome to today's class. As you know, Mathematics with Hudon is an online mathematics class that is purely made and designed for solving different topical problems in mathematics. So we come here week in, week out to solve different aspects of mathematics, different topics in mathematics, line by line, precept by precept, to ensure that students understand the nitty-gritty of mathematics. So today is not going to be an exception. And our topic for today is fractions. The question is that, what is a fraction? Fraction is part of a whole. Fraction is part of a whole, that is a whole number. One is a whole number. But by the time it is being divided, into numerator and denominator, or it is being divided to different parts, it is no more a whole number. So 1 is a whole number. So you can say 1 is what? Is a whole. Okay? So if you have P divided by Q, fractions is also the ratio of two numbers. When we say two numbers, we are looking at whole number. Fractions are whole number. They are integer. When we say whole numbers means integer. Okay? Whole numbers means integer. So if you look at this, the horizontal line dividing P and Q is called division line. Division line. Okay, so alphabet P, which is above the division line, is called numerator. Numerator. While our alphabet Q below the division line is called denominator. Okay? Sure. Now, we have P is our numerator, the stroke, horizontal stroke, is our what? Division line, and Q is the denominator. Then we move to what we call the pictorial representation of fractions. Pictorial representation of fraction. And before then, fractions have rules. There are rules and guidelines to follow whenever you are solving any fractional problems. So let's look at the rules and guidelines. Whenever you are given any whole number, I want to make it to be in fractional form. Let's say you have a circle like this. This circle is a whole, is full circle. Okay? Now, if I divide it into two equal parts, then I have obeyed the rules by shading one part. Okay? I must divide the circle equally before I can talk about fraction. If I don't divide the circle equally, then I'm disobeying the rules of fraction. Look at the second circle. The second circle. Then I cut the circle at the other side. Can you see that the aspect here, the area here, is not the same thing as the area here? Or you can see the segment here is not the same thing as this one. So this side is bigger than the other side. Okay? Side A is bigger than side B. Why for this part? Side A is equal in size with size what? Size B. Okay, so whenever you are dividing a particular shape, plane shape, ensure that you divide them equally. Is that okay? So that is very, very important. It's one of the cogent rules in fraction, especially pictorial representation of fraction. The same thing goes if you are trying to draw a triangle. If you draw a triangle this way, the second triangle, the first triangle, you divide it into 2 equal parts. Then you have obeyed the rule of fraction to shade this side. Then the other triangle, look at the way we are going to divide it. Can you see that this side is smaller than the other side? So for the first diagram, this diagram obeys the rule of fraction. Why this diagram doesn't obey the rule of fraction? While for the triangle, this diagram obeys the rule of fraction, while this diagram disobeys the rule of fraction. Very imperative. Okay, so let's look at different pictorial representation of fractions. So the first one is half. We have 1/2. Okay, so if you have a circle, okay, let's use another shape. Let's use a rectangle. Okay, you divide the rectangle into 2 equal parts, and then you shade one of the parts. Of course, make sure that the rectangle is okay. So you shade one of the what? One of the sides. So this is the pictorial representation for what? 1/2. Then let's move to another one. 1/3. 1/3. So 1/3. So if you have a circle, you divide this circle into what? 3 equal parts. As I told you earlier on, they must be what? Equal. Part 1, part 2, and part 3. And then I'm shading one part from the what? From the 3 parts. Okay, so that gives us what? 1/3. Let's have 2/5. 2/5. 2 divided by 5. Let's use a rectangle. Okay, so let's continue. Let's use a rectangle. If you have a rectangle this way, and you divide this rectangle into what? Into 5 equal parts. Part 1, part 2, part 3, part 4, and part 5. And then the 2 on top will be shaded. That is, you have 2 parts out of 5 parts. So you shade 2 parts or 2 portions out of it. Okay? Then let's also look at 2/3, which is second to the last. 2/3. Let's use rectangle again. So we divide this rectangle into what? Into 3 equal parts. First part, second part, and then what? Third part. Okay, and then you shade 2 portions out of 3 of the portions. I shade this first portion and the last portion, and that gives me what? 2 portions out of 3 portions. The other one, you shade 2 portions out of 5 portions. The other one, you shade 1 portion out of 3 portions. And the first one, you shade 1 portion out of 2 portions. Okay? So I'm going to give you assignments. The assignment is that you are going to draw different pictorial representation of fractions and show this to your parents, your guardians, or your teachers to mark for you. And that is your assignment. Show the pictorial representation of the following fraction. Assignments. Number 1, 2/7. The next one, 5/9. The next one, 3/8. And the last one, 4 divided by 11. So we have come to the end of today's class. My name still remains Okon Udom. and we have looked at different pictorial representation of fractions. An assignment has been given. Ensure you go through it over and over again and solve your assignment. Show it to your teachers, your parents to go through it for you. So before you go away, ensure you share this video to all your friends all over the world. Like, comment, share, press the notification button and subscribe to our YouTube channel so that you'll be encouraged to do more interesting videos for you. Until I come your way again next time, I say remain mathematically sound. Bye for now.